Here's a puzzle. You write a string into a zigzag pattern, going down then diagonally, up then down. After all that, you read it back row by row. Take PAHNAPLSIIGIR with 3 rows. After the zigzag, reading row by row gives PAHNAPLSIIGYR, same letters, totally different order. Try a smaller example first. A, B, C, D, E, F, G, with 3 rows. The letters go down the first column, then diagonally up, then down again, tracing the shape. Now imagine building this in a 2D grid by walking that zigzag. Look how many cells stay empty. Most of the picture is dead space we never visit. What if we skipped the grid wireframe and just kept 3 buckets, 1 per row? Each letter drops straight into its row's bucket. Watch the row index. Down it goes. 0, 1, 2. Hit the bottom, flip. Back up, 1, 0. Hit the top, flip again. That's the whole rule. Okay, back to PAYPALISHIIING. First letter P heading down, so it drops into row 0. Next letter A. Row index moves to 1. A lands in the row 1 bucket. I goes into row 2. We just hit the bottom row, so the direction flips. Now we head back up. Next P, heading up, means row 1. It tucks in right after the A that was already there. Next A, row 0. We hit the top, so the direction flips again. From here we head back down, and the dance repeats. Fast forward through the rest. Read the buckets top to bottom. Row 0 spells PAHN. Row 1 APLSIIG. Row 2 YIR. Stitch them, and that's your answer. Each letter is placed once and read once. The time grows with the string length. The buckets together hold every letter, 1 copy each. Same logic in Python. Edge case first. If there's only 1 row, there's no zigzag at all. Just hand the string back unchanged. Make 1 bucket per row, all starting empty. Track the current row index, and a step that says which direction we're heading. Walk each character. Append it to the current bucket. Flip the step at the top or the bottom. Move the index. At the end, join the buckets. And that's the pattern. When the picture has wasted space, skip the picture. Keep only what really matters.